Hi, ladies and gentlemen. So today we are going to take a look at synthetic division, the other method of how you can divide polynomials. So here's the warm-up to just remind you of what long division is and what it looks like. So take a moment to do this problem, then press play to see the answer. All right, so to remind you about long division, the very first thing we need to do is to set up our division here. So y minus 3 is our divisor. And the dividend here is going to be 2y cubed minus y squared plus 0y. We don't have a y term in the original problem, but in order to have it in standard form and with dividing, we need to have a 0 as its placeholder, and then plus 25. Y times what gives us 2y cubed? Well, that would be 2y squared. Multiplying the 2y squared by the divisor would give us 2y cubed minus 6y squared. 2y cubed minus 2y cubed is 0. Negative y squared minus negative 6y squared. That turns into negative y squared plus 6y, which is a positive 5y squared, and carrying down the 0y. Y times what is 5y squared? That's 5y. Multiplying 5y into the divisor, we get 5y squared minus 15y. 5y squared minus 5y squared cancels. The double negative with 0 minus negative 15y becomes positive 15y. And carrying down the 25. Last time through, y times what is 15y? That would be 15. We get 15y minus 45. Subtracting that, the 15y's cancel and give us 0. 25 minus negative 45 is 70. So we get our final answer of 2y squared plus 5y plus 15 plus a remainder of 70 over the divisor of y minus 3. So again, long division, yes, is a lengthy process, but is a repetitive process. Today we're going to take a look at synthetic division though, which is less lengthy and still slightly repetitive. So synthetic division is a shorthand method of dividing a polynomial by a linear binomial using only the coefficients. Polynomials must be written in standard form using 0 as a coefficient for any missing terms. Notice that that first bullet point is the exact same as what we had to do with long division and what we applied in the warm-up, inserting that 0y for the missing term. With synthetic division though, this only works when your divisor is a binomial, such as x minus some number, just like we saw in the warm-up problem. So there's a process to synthetic division. It's a 3-step process where step 2 kind of repeats. So let's walk through this. So the original part of this problem says 2x squared plus 7x plus 9. So notice the coefficients are positive 2, positive 7, positive 9. So here in this setup, we have a positive 2, positive 7, positive 9. So that's where those numbers are coming from. Then the thing we're dividing by is x plus 2. So notice we have a negative 2 here. You might be thinking, well, where's the minus 2 coming from because it says plus 2? You could refer back to Mrs. Walker's favorite phrase of x's always lie to remember that it's a negative 2. Or you could think of it as we're taking this binomial of x plus 2 and solving it for x. So I would subtract 2 from both sides. So we would get negative 2. And that solved version for x is what's going in this box here. And that's coming from the divisor. So you can think of it as the opposite of the number with your divisor. You can think of it as x is always lie, or you could approach it as solve for x. That's the number that goes in your box. So once we have this setup done, and we have everything in our box and all the pieces set up, very first step is to carry down your first number. Then you're going to take this number underneath your line and you're going to multiply that by the number in the box. In this case, that gets us negative 4, and that gets written above the line underneath your second coefficient. Then you're going to do the process, and then you're going to add straight down. So 7 minus 4 is 3. Then you're going to take this next number, multiply, take that product and write it in above the line next to the last value here. So 3 times negative 2 is negative 6. Add straight down and we get 3. And your last number should always end up in a box because that's representing your remainder. How that then relates to your final answer. So, the original degree of our polynomial was a 2. When we divided by x to a power of 1, we reduce our degree by 1 degree. So we had x squared to start with, we divided it, so x squared minus 1 degree is just x. And so these numbers here are giving you the coefficients starting with a degree of 1, reducing, and then that last number is your remainder. So let's put this to practice, as this is a very new process for you. But once you get used to it, it can really expedite this process of dividing polynomials. So looking at example 1, we're going to divide using synthetic division. Notice that our dividend is missing the x squared term. So I'm going to rewrite this in standard form, including the x squared term. So that would be 3x to the 4th minus x cubed plus 0x squared plus 5x minus 1. Now that I've done that, I'm going to identify our coefficients. We have a 3, a negative 1 technically, 0, 5, and a negative 1. So those numbers I have highlighted in purple, that's what I'm going to write to start off this synthetic division process. So 3, negative 1, 0, 5, and negative 1. Now I'm going to look at the binomial I'm dividing into, which says x plus 2. X is always lie though, so I'm really going to have negative 2 in my box that I'm going to use with this multiplication process next. I'm going to give myself a little bit of space underneath those coefficients of 3, negative 1, 0, 5, negative 1, and draw in a line. Now I'm going to start this multiplication and addition process. Remember, you're always adding these numbers straight down once we get into having that second row written in. We're going to carry the first number down. So carry down the 3. Now we're going to take the number underneath the line, multiply it by the number in the box, and write it above the line. So 3 times negative 2 is negative 6. I'm going to take negative 1 plus negative 6 to get negative 7. I've gone through the process or the cycle once. Now let's put that on repeat. The number underneath the line, negative 7, times the number in the box, negative 2, gives me a positive 14. Adding straight down, 0 plus 14 is 14. 14 times negative 2 is negative 28. 5 plus negative 28 is negative 23. Negative 23 times negative 2 is a positive 46. Yep. And then negative 1 plus 46 is 45. So this is where I end up with these numbers. These numbers underneath the line are my answers. Now, how this relates to what our answer is we are going to look at, what color do I want to use? Okay, so my original degree of my polynomial was x to the power of 4. So my original degree was 4. I've just divided it by x to a power of 1 though, from here, which means my answer for my degree is going to reduce by 1. So I know my first term was an x to the 4th, but after this division process, my first term is going to be x to the power of 3. It's going to be 1 less than the original polynomial. So I'm going to end up with an x cubed term. Now this coefficient, this starting number of 3, that's the number that goes in front of my x cubed term. Then I'm going to say minus 7 and x squared because each term from here on after is going to reduce by 1. Then I have the 14, which would be then with the x to the power of 1, or just x. Then minus 23. Now from there, x to the power of 1, if you reduce that by 1 gives you 0, and that really doesn't mean anything to us, so negative 23 is going to be our constant on the end. Okay, so x to the power of 1 is our smallest x term. Then we have our constant on the end, which is negative 23. That leaves us with this 45. 45 is part of the answer, but it's the remainder. So we're going to say plus our remainder, which is 45, over this original divisor of x plus 2. Oops, 2. So, though this process is much shorter, it is newer to you than long division is. So let's take a look at going through this process again using example 2.